So welcome everybody to the Chicago Cassandra meetup. Hopefully we'll do more of these more often. I've been running the Cassandra DC group for a while, and my goal is to have these maybe once a quarter at least, if not more frequently. Tonight's topic is basically a survey of real-time data platforms. There's actually one that's not on that deck that we'll talk about called Apache Pulsar. A little bit about myself. I'm a platform architect at Anant. We're a boutique consulting firm. We focus on business platforms, and we're a data stack strategic solutions delivery partner. That means we work with data stacks on very large accounts. And also we work with the commercial team who's also here. Peter, you guys will have a chance to talk about yourselves, where we deal with clients directly with the data stacks product. What we cover here, it says Cassandra DC, and that means, how do we get data into Cassandra? How do we get data out of Cassandra? What do we do with data when it's in? Whether it's data science, data engineering, data analytics, if it deals with where the data is sitting in Cassandra, let's talk about it. And now there's Apache Cassandra data stacks. There's 3 or 4 other variants. Yugabyte, Scala, Alessandra. So if they have a good, genuine talk about their technology, love to hear about it. So group rules. This is a discussion and not necessarily a presentation. So in the talk, if you have a question, just ask it. You don't have to raise your hand, just be polite about it. And you can also use that as an opportunity to talk about if you encountered that idea or something, you can talk about it. Just feel like I have something to add to this conversation, right? That's what we want. It shouldn't be one way, it should be a kind of a multi-way conversation. And I'm going to give the floor to Dee, who's going to talk a little bit about Wavical. Wavical is, co-hosting this event. And go ahead.
Okay, so I am very new welcome. So, but still I'm going to give it a try and tell you who we are. So we are a boutique niche data company. All we do is data, big data, machine learning and artificial intelligence, data management, data science, data visualization, all of those. And we are growing really, really fast, and we are hiring a lot. So right now we are about 200 employees, and 100 of them right here local, right here in this summer headquarters on the 6th floor, really great, location. And then we have 100 people offshore in Guatemala. So it's a really good mix of onshore. And data is the only thing we do. All the people we hire is are the data experts. And we are hiring 3-4 people a month. So we are growing really, really fast, and we have Fortune 500 clients that we're working with. And we are. I'll go to the next slide. So we love all the technology. Every your data sets, your Databricks, and your Sparks, your Talent, your AWS, your this, that. I'm just learning all those. But you will see that we are our staff, they are really, really highly skilled, and we try to get at all the cutting edge. If it's a tool or system that's good to add value in data innovation, we get certified in it, and we have also building really great partnerships. Bro, you're one of the partners too, and then you're one of the best partners of Talent. We won a bunch of awards from it, and we're doing the same thing with other data providers in there, so that we have that partnership. And we learn their tools really well and get certified, and we have people. So that's what I wanted to say, that technology is not if you have great technology, we'll learn it, and we will use it, and we'll give it to our clients. And we do all end-to-end, the whole architecture analysis. So anything else you want to know about this company? I'm happy to answer. And I'm really glad that all of you are here, and we will be doing the whole meetup too, because we have such a good space, and someone has.
And And party is upstairs on the rooftop, right?
Chicago somewhere.
We're gonna hold you to that.
The biggest partners together. So we'll have you, we have your, emails or whatever, like, we'll figure it out, we'll invite you over this point.
Thank you, Dee. Data stacks. Does anybody want to talk a little bit?
Well, I can just briefly. Have you guys, anyone not here in DataStax? Anyone not know who DataStax is? Okay. So DataStax was founded by one of the original people behind the Cassandra project, Jonathan Ellison. It was Rapano and Austin. Yep. Rapano, yeah. Rapano, thank you. So basically, we're the first company to commercialize Cassandra open source technology, and we provide a supported version of Cassandra. So we provide a lot of the drivers, a lot of the commits to open source Cassandra. So we're very involved in the open source movement for Cassandra. But we also have our own commercialized version for people looking for support. We have a tested certified version of Cassandra. We call it DDAC for DataStax Distributed. Thank you. Just call it DDAC for short. So, but it's basically a tested QA version of open source Cassandra 3.11.4, and it comes with support as well and some cool tools for help with bulk loading and everything. Yeah, well, that's enterprise. We don't say that for DDAC, do we? So anyway, but besides that, we also have our enterprise software, which includes the integrated Spark and Graph and Solar Search as well, and that one is a lot faster. To Tony's point back there, that's like we say 4 to 6 times faster than open source Cassandra. Probably most importantly, if you guys are looking for resources around Cassandra in general, check out datastacks.com and you look at the Academy section. We've got a lot of like self-directed educational content out there that you guys can check out if you want to learn more just about Cassandra. Some of the stuff talks a little bit about our commercial software, but there's a lot of great content if you're just learning Cassandra. I get reports every day of everyone hitting our website, and there's tons of people just like that have no interest in data stacks, but just learning Cassandra through our tools. So that's part of what our give back to the community. Great, thanks.
Thank you, Peter. I'm going to talk a little bit about Cassandra.Link. So this is a site that our company just launched, which actually Academy is a source of that knowledge. And then we also aggregate all of the expert blogs on Apache Cassandra into one site. In addition to the blog feeds, we have organized around 1,000 links curated about all things Cassandra. And that includes open source projects, whether it works on top of Cassandra or with Cassandra, et cetera. And it's searchable. But the top of the crown is really what's called Awesome Cassandra. It's on the top navigation, which is a table of contents style organization of articles about Cassandra. If you read all of these 400 links that I've curated, you'll know everything I know. That's what I tell people. Thanks again, Wavical and DataStax. And if you know anybody that would like to sponsor this group, either buying the pizza, getting us a spot to hang out, that's really all we ask for. Nothing special. I'd love to have you guys up here. Anybody have announcements? 15 seconds. Whether you're looking for a job or offering a job, or you have a meetup coming up. Dee, you guys are hiring, right?
Yeah, any level, product, technology side, or whatever. We should, actually go to the financial service background. So, like, if you are interested, whatever level you are in, going to be a team, follow up.
Great. Yeah, and our company works with a lot of independent consultants as well as we hire people. But our specialization is Cassandra, Spark, Kafka. If you've worked with it, we want to talk to you. And we're primarily a remote company. That's kind of one of the things that we offer is that we have part-time and full-time remote contracts if you're interested. All right, so today we're going to cover real-time platforms on Cassandra, Spark, Kafka, et cetera. But last week there was a talk in DC about multi-data center DevOps with Terraform, Ansible, and Ops Center. It had a really good draw. primarily because it had the words AWS and DevOps in it. And I think it may be a fairly popular event here too if we put it up. So maybe in September. But if you have an idea for a talk next month, please reach out. And if you want to give the talk, you can give it. In October, there's a Graph Roadshow in DC. The dates are getting finalized. And there's also a Data Week DC event. And I'm going to find out what other ones are around in Chicago, and I'll make sure the group knows about it. The weekly data engineering study group doesn't happen anymore, so don't worry about that. All right, so here's an opportunity for somebody here to talk about something that they know. So it could be about DevOps, it could be about DSC stack components, it could be about Cassandra, Spark, Kafka, and you know, it's really just, you know something and you want to just talk about it because you're an expert on it. So today's topic is a survey of real-time data platforms. I'm going to say it's going to be about 30 to 40 minutes. It may go over. And then after that, you know, we'll have some time to talk in general about it, free form. As I mentioned earlier, you're welcome to interrupt if you do it politely. And here we go. So our company, we design, build, and manage business platforms, leveraging data analytics tools like DataStax, customer experience platforms like Sitecore, info systems like QuickBooks and Salesforce, and other cloud software. You'll see in a minute what a business platform is. A business platform is a collection of platforms, actually, categorized in 5 areas. Data and analytics platforms, ecosystems platforms, info system platforms, IoT platforms, and a customer experience platform. In those areas, there are other software components that make up those platforms. And these systems are tied together with data and analytics. We focus on the real-time data and analytics platforms. And you know, we're going to talk about the middle portion of this platform diagram. But if you're interested in talking about this whole, what is a business platform? That's what really excites me. I'll love to talk about it afterwards. So what is the business use for real time? You know, why do we need real time? Why can't people just wait, right? Well, the reason is that, well, we'll come back to the reason of the current, the new thinking. The current thinking is that things can wait, that systems that need to talk to each other, they can go through this ETL cycle, and you know, it'll eventually get updated and people will get the intelligence. Now, this ETL, generally, we put data into a data warehouse, we have BI reports that come out of it, but ETL is also used for just synchronizing records between systems, like master data management. It's also used for getting data imported into a system from external third-party sources. It's also used to then export that data to third-party sinks. So ETL works, there's nothing wrong with it. It's just the new world order of business, the way customers interact, requires a real-time thinking. Today's business platform consists of Internet of Things, APIs that give access to partners, vendor channels, customers, etc. Customer experience platforms, which is a whole other ballgame that takes into account customer analytics. Information systems, which most companies have in the form of ERP, accounting, CRM, et cetera, et cetera, et cetera. And then data and analytics, the thing that connects it all. And the reason we have all these components today is because people, customers, partners, vendors, things, they all talk to the company anytime they want to. The reason why we have real time today is because everybody's interacting with the system now, right? You go and log on to your American Airlines app when you're about to check in now. You show your boarding pass now. It can't wait for 5 minutes. Kind of needs to happen in the next 1 to 2 seconds. And when you check in, the system needs to know that you've checked in, right? It can't wait half an hour for it because you just checked in. You got to get on the plane. That information is also valuable to the airport employees, maybe one level up. You know, how many people have checked in? Is there a ticket available? Right, somebody could call in right there, or they could use an app to buy a ticket right there. So all that stuff doesn't sit in one database. It probably never can. It sits in different systems and they need to talk to each other. So the new idea is that everything is basically going towards this idea of decentralized distributed systems rather than having a hub and spoke model. The way that companies are progressing, and they have been for a while, is by using kind of a central bus. There was a whole movement for enterprise service buses a while ago. And these enterprise service buses were heavy, but they were a precursor to kind of some of the stream technology that we're using now. So one of the things we're not going to really get to cover today, but distributed ledgers is really the future of business. A distributed ledger such as Kafka actually is a distributed ledger, but a distributed ledger in the sense of like a blockchain, right? Like a public blockchain or semi-public blockchain. In fact, Hyperledger, an open source project, can use Kafka as a ledger for verifying between peers for consensus. So when systems go towards this distributed model, things can't always have the data at all times. They just need to trust that data is going to get there eventually. Hopefully in less than a second. That idea of having applications just running, available, and useful to people is encompassed in a diagram from the Reactive Manifesto about applications should be responsive to the user. They should be maintainable and extendable to the developer. They need to be elastic and resilient if there's a lot of load. And the way that it happens is through message-driven architecture. Okay? If you look at any of the big applications that you use, modern business platforms like Uber or Lyft, or Uber Eats, which is a part of the Uber platform, they exemplify this reactive mentality, right? What's another example of a reactive application that's used today, like a modern application? Amazon is a really good example, right? They are the exemplar, actually, because they have things sitting in your house that you can order from. Multiple devices in my house, actually. You can order from your phone. And it also tells me on my watch when my deliveries are going to be late, right? Facebook is a modern application. Same type of thing, very reactive, very stretchable. What does this have to do with regular business? Well, the reality is that regular business now competes with Amazon. Every business now has competition from companies like Amazon, Google. Walmart is actually doing a pretty good job with their acquisition of Jet.com. But if you're not trying to be a reactive company, a modern business platform, more than likely it's going to hit you later. The companies that haven't, like Circuit City, and they're gone. Best Buy is still around. So a modern enterprise basically has components talking to each other using streams and queues, and an idea of an actor, which is an independent object that can just come into existence and basically do something and then be done with it. And that idea of an actor sometimes is done through software like Akka or with Lambda functions or Azure functions. The streams and queues, they can be in things like Kafka, Kinesis, SQS, SNS, RabbitMQ. You could even consider MuleSoft in there. MuleSoft is more like an enterprise service bus. But there is this middle ground in which you can kind of do what the ESB does, enterprise service bus does, and what a pure stream or a queue does, which just deliver messages. The question is, what are you trying to do? Some of the models that are out there today, the open source models, one is called the SMAC stack: Spark, Mesos, Akka, Cassandra, Kafka. Mesos not necessarily a competitor to Kubernetes, but is often seen as a competitor to Kubernetes, is no longer being used. It's too bad. Pretty good technology. But instead of Mesos, people basically don't use Mesos, or they use Docker or Cassandra. In that, there's basically a distributed computing engine like Spark. There is a event processor like Spark Streaming, and Akka is also an event processor. There is a distributed storage mechanism, persistent storage mechanism like Cassandra. And then there is a distributed message queue like Kafka. Now, three of these components you'll see over and over again in these diagrams. And I didn't put them there. They're just there on the internet. That's Cassandra, Spark, and Kafka. And the reason is why. We'll get to that in a second. Other technologies out there, Flink. Flink is also written in Scala, like Spark, but it began its root in stream processing, whereas Spark was really the next iteration of MapReduce as a batch processor. The pattern of an event stream, an event processor, and a really good storage mechanism is everywhere in business. It just matters what you're using for what. Why do people use Cassandra, Spark, and Kafka over and over and over again? It's because Cassandra is linearly scalable. As more data comes in, as more traffic comes in, as long as you keep adding hardware, it will keep scaling linearly. Same thing with Spark, although you have to be a pretty good data modeler and a programmer to make sure that Spark programs are distributed properly. And then Kafka, same thing. It scales linearly. If you have more data, you add more brokers. And they're resilient. All three of them are resilient. They're meant for high availability. That's why people use Cassandra, Spark, and Kafka. Now, it may not be that they use all three of these components. It may be that they use Cassandra and Spark, but not Kafka. They're using RabbitMQ. I don't know why. It's easy. Or they may be using Flink and Cassandra and Kafka, right? Or may they not be using Cassandra? Oh my God. They're using Redshift or DynamoDB or Snowflake because they don't need a real-time read of the data. They just need to get data in there, right? But we could go on and on and on about these patterns, but ultimately it comes down to these ideas of a good storage mechanism, a good stream, and a good stream processor. And that pattern you can do in one computer, or you can do it in hundreds. Most platforms, data platforms, could be boiled into, this is my diagram, I didn't steal this from somewhere, into this basic idea of getting data in, getting data out. You've seen it in different ways. There are sources of data, systems and devices, cloud applications. Maybe you have an API that gets data in there. And when I say cloud apps, that could be anything, right? Ingress, sometimes it comes in as a batch. Sometimes it's a stream. Sometimes you have another internal API for people to just put data into. And the stream processor is either scheduled or it's in real time. Once the data gets in, so maybe there's an internal queue, it tends to go to some sort of relational database and some sort of non-relational database. Why do they use both? Well, you can't do everything in non-relational, and you can't do everything in SQL, in relational. Finally, after the data is sitting around in a data warehouse, maybe you do analytics on it. What that analytics means, it could be business intelligence, just reports, descriptive analytics. It could be machine learning, predictive analytics that creates reports and basically, hey, this is where things are going. Or it could be prescriptive analytics where it's telling you what to do based on what's happened. And it could actually send out events. Right? And those things then go out to outgoing API, cloud apps, and servers and devices. But it's never one way. This is a super simplified version of what really happens. The reality is there's tens, if not hundreds of things coming in and tens of hundreds of things coming out. And sometimes there's loops inside You may have some data coming out, going back into your data platform. So that type of load, if it was just a batch system, you'd do it once a day and you'd be happy with it. But as we just talked about, is you can't have it just once a day. You can't just have it 4 times a day. It needs to happen all the time. And even for a moderately sized business, that requires real computing power. And you know what? Nobody buys mainframes anymore. So what's the next best thing? Is to have distributed computing. So generally speaking, when we talk about real-time analytics, we're talking about deterministic available. Now, machine learning has both deterministic and non-deterministic outcomes. Data enrichment, maybe you get data, you make it, you enhance it, you put it back. It may include built-in business intelligence, visualization, or you may add it. And sometimes you want SQL. There's nothing as simple as a good SQL statement that can give you a report based on the data that you have. Data, everybody has different types of data. S3, HDFS, Cassandra, Redshift, RDS. Why did I mention those? Because they represent wildly different types of data systems. S3 being a digital file system, a distributed file system that basically mimics HDFS. And now there's different cloud vendors that basically conform to the S3 protocol. Like Azure also has this. Cassandra being a distributed real-time read and write system. Redshift being a system that scales as data gets in and is used to crunch it to get information. Now, Redshift is great for doing analytics on data, lots and lots of data. But if 100 people hit it, or 1,000 people hit it, or 1 million people hit it, it's probably not the right technology. Right? RDS, Relational Database Service from Amazon, pretty good technology, right? We have SQL Server, Oracle, Postgres, MySQL, now Aurora DB at Amazon, and Azure also has its own version of that. They're always a Me Too company. These are great, but at least in RDS in Amazon, Aurora DB is a pretty good master. They claim to be master and master. It can scale until you get to a certain data point. These systems are doing writes on both ends, but eventually they're just copying data to all the nodes. And you can't have more than a certain amount of information in one computer. On the analysis side, Spark and SQL are kind of the de facto things now. Of course, you can always do analytics with Python just running on your computer, or R on your computer. But Spark has now basically become the de facto system for basically anything distributed, right? And you can program in Python, Scala, Java, or R in Spark. That's why it's really become popular. You can come to it from different angles. And then SQL has been around forever. It's not going anywhere. And in fact, Spark also has something called Spark SQL. So real-time analytics, it should have the following components: being able to get the data from different systems and being able to get the information out in fairly quickly. Common architecture that people do today is they meld batch and real-time. They meld the batch because sometimes you really have to deal with a lot of data to do a proper model creation, let's say in the world of machine learning. But on the speed side, you want something that's streaming. Because maybe you just need to save data or do a lookup and enhance something, right? And eventually, the data goes into a serving layer. And the serving layer meaning that once the data is created, it needs to be read. Cassandra is a common tool that's used for that. But this Spark or Hadoop, Kafka / Storm, and Cassandra / Druid / Apache HBase, these are basically showing other components that you can replace. So although Kafka itself is a an event bus, an event broker, it also has some stream capabilities. That's the reason why they put that there. All right, I'm gonna pause for a second. Any questions or any comments or any additions so far? Any corrections? Okay. Yes. Well, it depends. If your batch needs to look at, let's say, 10 years worth of data, and it can't happen in that particular time, then
But I mean, this picture.
Yeah.
Have both of them really bad compensating for problems. with these people, right?
Yes.
Right. It's not enough. You don't trust them completely. They write data and whatnot, right?
Yep.
Calculating stuff. Batch, right?
partially it's for that. Partially it's for recalculating and reconciling, but partially batch is still used for just a tremendous amount of data, which is different function than what you're talking about. But yeah, Flink is pretty good at that stream process.
Then do you really call it Lambda? Because Lambda is really doing the same set of data.
Yes, it's for reconciliation.
So
For reconciliation. It's probably just Lambda plus. Yeah, because I have a colleague who works in government and in the intelligence space, and the data that they have, Spark just cannot handle it. It's petabytes on petabytes of information, and MapReduce, because Spark does everything in memory, unless you actually checkpoint and save data back. MapReduce, on the other end, is get data, you do something with it, you save it back, and it eventually it'll go through it. And so in those cases, it is a brute force batch process, and you just can't do anything about it. Spark could do it, but then you have to go back to basically doing MapReduce on Spark. Take data, process it, save it, go to the next thing in the pipeline. And that's not a bad thing to do either, which is to break up everything into micro processes. And that's really what the Akka model is about, is everything becomes a small distributed compute unit that is coordinated through messages. And in that case, your data neither needs streaming nor batch, because the state of the system is basically available to you, right? So that's kind of that's like the ultimate goal, is that you get the data as it is when you need it. And it's always kind of like in flux. And so Akka is actually used in the stock market because of that reason, that it actually never sits anywhere. It's just in flux, always available. Couple components that are used. So Kafka SQL. Anybody know about Kafka SQL? KSQL? All right, one guy. All right. So KSQL is basically a materialization of a topic where you're setting field value pairs using a topic message queue. It basically makes it into a table. Kafka Connect is I will say it's an ETL framework. You have sources and you have sinks, and it's a declarative system in which you say, here's my source, here's the configuration on how to get it. Here's my sink, here's the configuration where to send the information. And this is the topic that I want to use as a channel. And then you just start it up. And Kafka Connect has its own clustering mechanism, and it just polls the system and sends data in. So with Kafka Connect, you could say, get data from Kafka, save it to Cassandra. Get data from MySQL, put it to S3. Get data from Kafka, send it to Kafka. But I wouldn't use Kafka Connect for that. I would probably use Kafka Streams, which is down below. Samza is a system that's built on top of a distributed log. It's kind of like a database, but it materializes information based on the log. Akka and Alpaca are related. Akka is an actor system, which basically says, get a message, do something with it, save it, or sorry, send it to somewhere else. And an Akka program is basically a hierarchy of programs that just send messages back and forth. You can have Akka in your API layer. You can have Akka in your processing layer. You can have Akka in your persistence layer. There's even, some distributed databases, I think, that are built on top of Akka. But what I like about Akka is that it is the ultimate definition of a microservice. It just comes into being and goes away. for one little thing, and it's supposed to just happen like that. Why Akka and not something else? But Akka is basically it's open source and you can get access to it. Alpaca uses streams that are built on top of Akka, and it's a declarative ETL framework, but not as declarative as you think. You basically write a small Scala program and you say, take data from here, send it through. And the cool thing about Alpaca, it has back pressure built into it. So as data comes in, it can check to see if the sink is too busy. And if it's too busy, it can say back to the source, hey, just hold up for a second. Give me data a little bit more slowly. Right? For message enhancement computation, Kafka Streams, as I mentioned earlier, you basically are able to instantiate objects such as K-table or K-streams in your program and send data to other K-streams and K-tables. And this just runs in a cluster on top of the Kafka broker as a data store. Spark, Flink, I don't know why I have Kafka Streams there twice, maybe because I like it so much. No, sorry. And serverless functions, so AWS Lambda, Azure Functions. There's also serverless frameworks that run on top of Docker and Kubernetes that basically allow you to have the benefits of AWS Lambda or server or Azure Functions, but without having to be tied to a cloud vendor. On the right side, we basically have real-time distributed data. So Cassandra being, really great for read writes. We have S3, which I think is basically the best data storage system in the world at this point, where it's like a wormhole. You put data into it on one side of the world, and it's available on the other side of the world, and there's nothing else like it. Google has cool stuff, but S3 is available to everybody. And then DynamoDB, one of the precursors to Cassandra. It's good for certain things. It's not great for other things, but it's one of those ready-to-use distributed data stores. There's another world of real-time analytics, which is this co-located data and analytics, meaning, normally in the big data world, you have your data storage, and then you have your system to analyze that data. But if you were around before big data, you would just have a database server, and your data was there, and you could do SQL on it, right? So Redshift is in that line of technology. It makes all this data available via PostgreSQL syntax. Snowflake, similar but better technology. You don't have to be tied to AWS. And both of them can take heavy writes. But their issue is that they're not really meant for heavy reads. Okay? So you can't put an API in front of it and expose it to the world. The other option is Cassandra with Spark. Cassandra with Spark and Solar, or Cassandra and Spark SQL. This can be done either using all of the open source components, at least in the first two, fairly easy. Cassandra and Spark and Solar, technically you could do it with Cassandra, Spark, and Elasticsearch as well. You have to do a lot of work to make them work together, to keep data synchronized. But they're also available together in DataStax. So we talked about the SMAC stack. And what I like about this is from the Mesos site, ironically, is that this idea of feeds, analytics, distributed DB, and reactive application, really, you can use any other technology in its place and you can get the same effect. This idea of using Mesos is no longer exclusive to Mesos. So Docker and Kubernetes is the stack now. All right, let's take a quick pause for a second. So we've talked about a lot of different components in the real-time stack. Any questions in general or any ideas or problems that you guys are facing that when we go through some of these components, we can dive deep into? Okay. So Apache Kafka, a bit of history. Apache Kafka was created at LinkedIn because they had essentially a data synchronization problem. They had tons and tons of systems, some that were basically users were using it, some that were basically for them to analyze their social graph. They had jobs systems. They had, LinkedIn is basically a talent company. They're classified as talent software. So they were selling access, different subscriptions. So all these systems basically had to be tied together. And they had so much information changing all the time that they couldn't do this with technology that was available. So they ended up in basically creating Kafka. That's where Kafka came from. Today, Kafka is more than that. Partially, it's used as an event store where some data comes in, you basically store the event in Kafka, then the event handler updates the application based on that event. That's cool because if you need to move from one platform to another, you can just replay all your messages in the new platform. Your data migration is much easier. And people use this today. Massive systems, right? I'm talking 30, 40 terabytes of actively managed data. They change something in the schema, they change something in the API, they just use Terraform, Ansible to bring up the new stack, and they replay the Kafka messages, right? So their system is already in real time, but the added benefit of using Kafka is that they can basically replay all of their data. Now, Kafka also has this Kafka Streams. And what this is from the Confluent blog. What they're trying to say is you don't need to write your own event handler. You don't have to have your own code or framework for this. Just write a Kafka Streams topology that says, take my data, do this with it, and be done with it. And now Kafka Streams runs on the JVM. So you could program in Java or Scala or Groovy if you wanted to. But it makes it convenient to kind of have everything in one ecosystem. Here's an example of Kafka, Spark, Cassandra, SQS, and Redshift on AWS. So they receive events. They send them through SQS. They validate, clean it, and then they send it to Kafka and S3. Why would they do that? Well, S3 is a great data store. They can archive stuff there. It's the cheapest data store. And then once it hits Kafka, Spark Streaming can pick it up, or in this case, Batch picks it up from S3. And eventually, it goes to Cassandra for real-time visualization, or Redshift and S3 for when we see analysis, that analysis now means there's actually active filtering in S3 now. Pretty cool. But you can have Hive running on top of S3, or you can have your Redshift SQL connected to Tableau. Right? So this is actually a slightly older diagram, but still very relevant today. The big thing to note here is that this is open source Cassandra. And when we talk about real-time visualization, we are producing the data that we want to receive. There's no analytics on this side, on this particular diagram. Analytics is really on the bottom part. Kafka Streams again, basically showing an example of having data come in to the stream, and then having a couple of different services that read and write to topics as a way of managing the business state. It's a different way of thinking, meaning you don't have application servers, you just have a topology of streams, and that's basically what does the business flow. The assumption here is that everything comes in as an event, and then everything is managed as an event. And eventually, when you get the information, You can actually get it from Kafka, but it won't be able to really be scalable. So you have to save it somewhere that can be scalable, like Cassandra. So this diagram shows how Kafka Streams can be used with data stacks. So in Kafka Connect, there is a officially supported data stacks connector now, where you can connect it to a Kafka topic and essentially have that data written to Cassandra table. As data comes in, it just handles it. And it's running on top of the Kafka Connect infrastructure, which is declarative. So if you have 100 streams and 100 tables, you just declare 100 connections and it'll take care. And you don't have to maintain special code. You're just maintaining your source and sync configuration. Kafka is also used for machine learning, and this in particular shows that you can use Kafka Streams for modeling, as well as taking data out, evaluating it in real time for the production system. Now, I haven't tested Kafka Streams for machine learning, but I mean, if Confluent says they can do it, then they can probably do it. So Kafka Streams is a pure Scala application, right? When we're talking about machine building there, it's using Scala machine learning libraries, but if you're not really, this doesn't have any Spark in it right now. Yeah. This is just, what's that? It's whatever is available in the Scala ecosystem. So technically you can use Spark machine learning libraries with Kafka Streams because it's basically all jars. Okay, but I'm not an expert on the machine learning aspects of Kafka Streams. I can't tell you specifically which library, but I know that there's like Keystone ML, for example, runs on Scala, but also in Spark. Okay. All right. Apache Spark. It's kind of the most well-known. So we have Spark streaming, Spark using some static data sources and streaming data sources. So this is the most common use of Spark, stream and batch processing. With Spark SQL, it's sometimes used on the actual data sources or data frames that you create. There's a lot of potential here. And one open source project uses that potential, and that's called PhiloDB. And PhiloDB is a columnar store, not a column store, but a columnar store on top of Cassandra. And it runs on top of Spark. And what it does is it has an API to insert data, and then it has a Spark SQL view of that information. But it is 10 to 20 times faster than Spark SQL on joined data. And the reason is that Spark SQL, if your primary and foreign keys is not connected together properly and distributed properly, Spark is essentially scanning the whole table to get that information and filtering. But they do that same thing in a columnar store, which is optimized for arbitrary queries. It works pretty well. If you're using data stacks, Solar happens to power the index, and it can really optimize a Spark SQL. I don't know how long you guys have been in the industry, but I've seen every different BI tool come and go, right? MicroStrategy, Cognos, man, business objects, Crystal Reports. Oh man, I remember using Crystal Reports, and the .NET objects came out, and I was like, oh my God, these are amazing. SQL Server reporting services, you know, MicroStrategy, which, you know, Webgold's they're experts at, and now it's Tableau, right? So Tableau, there's actually a Spark SQL connector for Tableau, which means that as long as you have Spark SQL running, you can do queries on a massive set of data. Now, Spark SQL can run on anything because Spark can work with anything, right? So as long as you properly create your data frames that are available, Spark can then go retrieve them and do joins on them, and do cool stuff. If you happen to use DataStax, you can do joins on the tables that are inside Cassandra. But you don't have to. As long as Tableau is connected to you know, one of your analysis engines, you're able to get access to that data. I'm going to fly through some of these. Apache Kafka, Apache Spark. It's just another variation of what we saw earlier. Data comes in. We have Kafka Source Connect and a Kafka Sync Connect, taking data from one place, sending it to another. But you can have Spark in the middle, analyzing that information in real time. That also means that you can publish data back to the stream that gets sent somewhere else. It's not just old data going to another system, but you can have old data that is enriched and then also sent to new systems. Here's another example of Lambda with Kafka and Spark, using Spark for the batch and Spark for the stream. So there's an example called Killer Weather that it's open source that shows how to do Spark, Kafka, Akka, and Cassandra. Because people always ask, why do I need to use Akka if I've got Spark streaming, right? And it looks like this. Data comes in an Akka cluster that actually has exposed its input as a REST API. Sends the data to Kafka. Spark takes it over, Spark streaming and Spark batch, and sends data to Cassandra. Data comes back through Cassandra and then send messages back to Akka. So if you're using a web interface, this thing can essentially take real-time events, save them, do machine learning on them, and then send them back to the user. Right? I'm not talking about like a polling system. I'm talking about everything is going one way, pushing all the way back. Okay, so the type of system that you see in Facebook or Twitter, right, when somebody adds you as a friend or sends you a tweet, is not too dissimilar from what this is right here. Okay, which is everything is happening in real time, and there's some batch processing happening as well. Another example of Akka, Spark, Kafka, and Cassandra. This is from, the, I believe, the Lightbend portal. They're the people who manage Akka. Play is a framework, it's a web framework that is built on top of Akka. Data comes in, gets put into Akka Streams. That data gets put into Kafka, and then goes back to users. After it's massaged, it also goes into Spark, which then saves data back to HDFS and Cassandra. Common thing being that Spark is great for really crunching the information. And Akka is really good for moving information very quickly, in the sense that Kafka stores a message. It's not really moving anything. Something else actually has to do the work. Right? Spark does the work, Akka does the work. So why not use Kafka and, sorry, why just not use Cassandra for everything? Or why not use Kafka for everything in terms of storage of information? Right? That's a really good debate. Here's my take on it. Kafka, Cassandra, Solar, RocksDB, they all are underlying, at the end of the day, the same thing. They take data, they put it into a distributed ledger, they basically have consensus on that ledger, and then they say this is the truth, right? Kafka can take writes faster than anything out there and tell you that this is the truth. But it doesn't have the capacity to distribute the truth as good as Cassandra does. Cassandra can take data in really fast, and it can give data back out really fast to millions of people. Kafka cannot give that data back to millions of people. It can take millions of writes, but it can't just give it back. That's why we use Kafka and Cassandra. So now you understand like why there's 4 components in this pattern and not just 2, right? Why not just Spark and Cassandra? You can kind of do what you need to do with Spark. It's just that when you get to a big enough state where there's enough things happening, you need to have specialized components. Akka Streams and Alpaca, which I mentioned, really amazing technology. It's fairly new, but they have lots of great examples where you have like a CSV file, it picks it up, sends it to Kafka. Or you have a Kafka sync, process it, puts it into CSV. And it's very declarative. It's like Kafka Connect, but it just says, pick it up, do something with it, put it here. Now, the new player in the game is Apache Pulsar, and this is the last topic today. Apache Pulsar is from Yahoo, and I feel like they just wanted to be cool, and they wanted to make something better than Apache Kafka. But Pulsar, the cool thing about Pulsar is that it actually is Kafka compliant. Now, I was hoping that Pulsar would not have a dependency on Zookeeper, but it does. Can't really get away from it. But the unique thing about Pulsar is that in addition to having a Kafka compliant interface, it allows you to use its Pulsar client to do specialized topics. Those topics being either an exclusive subscription to the topic, meaning only one consumer. A shared subscription, meaning you have potentially 2 consumers, basically it's broadcasted to both. Or a failover, meaning that one consumes it, but then you have potentially another one that can take that message also. You don't have that type of functionality in Kafka. And this is essentially the difference between SNS and SQS, right? Notification system, you can send it to a bunch of different subscribers. SQS, you send it to one and one thing picks it up. Why would you need both? Well, you need one because you want to guarantee a particular order of events. You need another one because you want to notify everybody of an event happening. And you need a third one because you want to make sure that an event comes in and is reconciled somewhere. This middle one is the most powerful, I think, because if you're really connecting multiple systems together, you want to make sure that everybody gets the same message, right? As the Rachel Maddow show, as she says, you know, watch this space. I don't know if you guys get that. Watch this space. It also has geo-replication, right? Now, Kafka has geo-replication only with something called mirror, Kafka mirroring. And different people have done different mirrors. There's a Kafka mirroring tool by Uber. They've implemented it. And I think Confluent has also implemented one as well. Mirror Maker. But Pulsar has this built in, kind of like Cassandra. So as I said, watch this space. It's really cool technology. And it has tiered storage, where older data can get put into S3. Like Cassandra also has tiered storage. Watch this space. That's the presentation. We covered a lot of topics today. But at the end of the day, what I want you guys to walk away with is that the technology that runs Silicon Valley is available to everybody. And the things that they do is, it's not black magic. It's not some esoteric science. It's actually available, open everywhere. The patterns are all available. Like all these diagrams, I probably need to go back and put little where I got the image from, but I didn't make any of these diagrams except for one of them earlier, right? The architecture patterns are available online. If I were to spend time, however, really get to know a technology, and this is where I plug in DataStax, I would spend time on DataStax and Confluent because they're commercially supporting Kafka, and DataStax is supporting Spark and Cassandra. The other technology that you know, really I think starting to tie it all together is Kubernetes. It's complicated, but Kubernetes is the other factor in this real-time space because it allows you to develop microservices that are going to be getting those events and receiving those events and giving them to the user, right? Where are your apps going to run? Your applications aren't going to run on Spark and Kafka and Cassandra, right? They're going to run on a web server. Where are your REST APIs going to run? They're not going to run on these components. So if you want to build a reactive platform that can address events from millions of people and send events to millions of people, then you kind of have to look at the big picture. Your data and analytics is the middle of it, and Kubernetes, or whatever comes afterwards, that allows you to manage applications that talk to it is the next layer that you need to worry about. And then beyond that, maybe your phone, maybe your watch, maybe your Alexa, Google Home, Apple TV thing that is talking to. So I'll be here for a little while if you guys want to come and chat, but thanks a lot, guys.